Hello students, welcome back to all. Today in this video, I would like to explain about isomerism. So, what is meant by isomerism? Let us see. So, before to know what is an isomerism, we should know about what is isomers. So, compounds which are having same molecular formula, note this point, but differ in physical and chemical properties are called isomers. So there are so many compounds in organic chemistry. All the compounds may not having same molecular formula. Different compounds having different molecular formula. But here the isomers means they should having the same molecular formula. Which means, for example, C4H10 is there. So this is the molecular formula of the compound. But there exist different in their physical and chemical properties, which means each of molecule having some molecular formula but different in their structure as well as physical and chemical properties. So those are called isomers, and this phenomenon is known as isomerism. So this is very important. So isomers means having same molecular formula and different in their physical and chemical properties. So this phenomenon is known as isomerism. So now let us see how many types of isomerism will exist. So generally isomerism is of two types. One is structural isomerism and stereoisomerism. Structural isomerism means it basing on the structure. Is it okay? Stereoisomerism means basing on the spatial arrangement. So like this, the structural isomerism, so there are so many types of structural isomerism is there. So the first one is called chain isomerism, and second one is called position isomerism, and third one is called functional group isomerism, and fourth one is called metamerism. And another one is called ring chain isomerism. And tautomerism is also one type of structural isomerism. So we will discuss today what is a chain isomerism in this class. The remaining isomerisms will be covered in the next videos. So what about the stereoisomerism? So the stereoisomerism is generally classified into two types. So what is the first type? Configurational isomerism. And the second type is conformational. So here we have to remember one point. This configural isomerism I am writing here is again classified into two types. So first one is called geometrical and second one is called optical. Is it clear? So we know what is an isomerism. So the classification of isomerism. Generally isomerism is classified into two types. Structural, basing on the structural. So first classification is known as structural isomerism, and second one is called stereoisomerism. Is it okay? So again the structural isomerism is having different kinds. So chain isomerism is there, position, functional group, metamerism, ring chain isomerism, and tautomerism. So these are the four main types of structural isomerism, and ring chain isomerism and tautomerism is also one kind of structural isomerism. And while coming to the stereoisomerism, it is also classified into two types: configurational isomerism and conformational isomerism. So this configurational isomerism is again classified into two types: geometrical and optical. So this is what the classification of isomerism. And now in today's video we will discuss about what is chain isomerism with examples. So now let us see what is a chain isomerism. So chain isomerism means very simple here, when two or more compounds having similar molecular formula. See here, the compounds having same or similar molecular formula but different carbon skeletons. So these are termed as chain isomers and the phenomenon is known as chain isomerism. Which means, for example, they are having similar molecular formula but different in their parent chain. Or branched chain. Which means having similar formula, molecular formula, but different in the structure, different in the carbon skeleton, or it may be differ by parent chain or branched chain. Let us see some examples. For example, so C5H12. So generally this is the molecular formula of the compound C5H12. It can exhibit three types of different compounds. Let us see. CH3, CH2, 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 CH3. So the name of the compound is pentane. Let us see another one. CH3, CH, CH3, CH2, CH3. So the name of the compound is called isopentane. Let us see another example. See, CH3, CH3, CH3 and CH3. So the name of the compound is neopentane. See here, while observing these three compounds having similar molecular formula, same. In the first case there are 1, 2, 3, 4, 5, 6, 5. So there are 5 carbon atoms and hydrogens also 12 here. 3 plus 2 plus 2 plus 2 plus 3. So total number of 5. So the name is pentane because it is containing C5H12. While coming to in the second case, so here also 1, 2, 3, 4, 5. So 5 carbon atoms are there and hydrogens 3, 6 and 7, 10 and 12. So here also C5H10. There is no change in the molecular formula but structure is different while observing this. So it is containing only one parent chain. While coming to the second compound, it is containing one branch. One methyl group is here. One branch is there. So the name is obviously changed here, isopentane. So IUPAC, in IUPAC you maybe call it as 1, 2, 3, 4. So obviously 2-methyl. So another name is 2-methyl butane. See, because at first, second, third, four carbons are there. So butane, and at the second position methyl group is there. So the name is 2-methyl butane. So here structural formula is same. But here the name is also changing here and structure is also changing here. Molecular formula is same but different by their structure. While coming to the third compound, see here the first carbon atom is attached by 4 methyl groups 1, 2, 3, 4. So obviously it is called neopentane, or another, according to IUPAC name, what is the name of the compound? So see here 1, 2, 3. So 3 carbons are there. Obviously propane. At second position, 2 methyl groups are there. So obviously 2 comma 2 dimethyl propane. So this is the name of the third compound. So while observing these 3 compounds having the C5H12 molecular formula, but they are vary by their structure. So this is what chain isomerism. Is it okay? So now let us see some more examples basing on this chain isomerism. So second example, C4H10. So let us see, it can be in 2 types, in 2 compounds can exhibit the similar molecular formula. CH3, CH2, CH2, CH3. Obviously 1, 2, 3, 4 carbons and hydrogens 10. So C4H10, similar molecular formula. So obviously name is N-butane. See, in the second case also CH3, CH3, CH3. So here also 1, 2, 3, 4 carbons and hydrogens 3, 6, 9 and 10. So obviously it is also having C4H10 structure, similar molecular formula, but here it is containing one branch. So it is containing only one main parent chain, it is containing branch in the second case. So the name of the compound is 2-methyl propane obviously. Is it okay? So common name is isobutane. Now let us see one more example. That is third one, C6H14 structure. So this is the C6H14. So how many molecules can exhibit this same molecular formula? Let us see. So CH3, CH2, 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 CH3. So this is hexane and hexane. Just wait. And second case CH3, CH3, CH2, CH2, CH3. So obviously here 1, 2, 3, 4, 5. At second position methyl group is there. So obviously the name is 2-methyl pentane. So let us see third one. CH3, CH2, CH3, CH2, CH3. See here, here at the second position methyl group is there. At third position, so obviously 3-methyl pentane. See, while observing here, in the first case N-hexane 1, 2, 3, 4, 5, 6. 6 carbons are there and 3 plus 2 5 plus 2 7 plus 2 9 plus 11 and 14. So N-hexane. So in the second case also see here the structure is changing here. One branched chain is there. One methyl group is there. So 2-methyl pentane. So here also 1, 2, 3, 4, 5, 6 carbons and hydrogens also 14. While observing here, in the 3 cases having the similar molecular formula, but the structures will be changing here and the name of the compound will be changed. So if the methyl group is at third position, the name of the compound is 3-methyl pentane. And another 2 compounds also having the similar molecular formula. Let us see. The fourth one is CH3, CH2, CH3. See here 1, 2, 3, 4. At second position 2 methyl groups are there. So obviously 2 comma 2 dimethyl butane. So another name is called neohexane. See, in this case, at second position, 2 methyl groups are there. Here also 1, 2, 3, 4, 5, 6 carbons and hydrogens also. Total number of 14 hydrogen atoms. So this is what the fourth possible structure. And fifth compound, CH3, CH3, CH3 and CH3. See here 1, 2, 3, 4, 5, 6. Here also same molecular formula. The name of the compound is at second and third position methyl group is there. So obviously the name is 2,3 dimethyl butane. So this is what the chain isomerism. So chain isomerism means having same molecular formula but different by their structure or skeleton. So this is what today's class. Thank you.